Everyone to the mid-year exam revision session itself. All right, so today we'll be covering a total of 4 different topics. What are they? So we're going to be doing energy changes and electrolysis. All right, these 2 topics are for chemistry. For those of you who are taking combined, right, electrolysis is not relevant for you. Okay, so just stay around for the energy changes portion. Of course, for those who are taking chem bio, right, you can obviously skip the physics part and maybe come back towards the end for the giveaway. Now, for those of you who are taking pure chem and pure physics, all 4 topics that I'm covering today is highly relevant. I'll also be going through some commonly tested questions just to prep you ahead of your mid-year exams. Now, I know not all of your schools have mid-year. For those of you who don't have mid-year, take this as a good revision session of sorts, right? Refresh your content, see what kind of questions can be set. For those of you who mid-year exams are in a few days' time, or most of you would be next week, right? I think all of this will be very important and very relevant. Of course, right now, if you have like your school notes with you, your textbook, or those you write your own notes kind, take it out. There'll be important things I'll be requesting for you to take down later on. All right, so be prepared to write things. Okay, don't just listen. If you just listen, you're not gonna fully absorb everything. Okay, so make it a point to take down notes as I'm teaching. And if not, let's jump into the introduction here. So for those of you who are new, okay, this is a quick self-introduction. I'm Daryl. I mainly teach O-level chemistry and physics. Small hint, this is slightly relevant to some of the Kahoot things that are going to appear at the end. All right. So I've been teaching for 8 years already. Okay. And for me, I mainly do group tuition and crash courses. So we do have upcoming crash courses in June. I will share a bit more about that later on. So for now, I'm just like taking care of many students under my group tuition. Last year itself, the crash courses was it was a great success. I mean, we had 200 plus students coming down for chem and physics. And I think majority of them rated it a 9 or 10 out of 10. So that was pretty satisfying for me. Okay, but this is just a little bit more about myself. Now, for those of you who are wondering, yes, there will be a giveaway at the end. So that would start around 6:20. So please be around by then if you want to participate. Okay, it's a Kahoot quiz. The winner will walk away with 1 set of curated notes of your choice, either chem, physics, or combined science. Okay, so that is it for the end. Now, a quick revision tip, right? For those of you right now who are a little worried about your mid-years, you don't really have much time, right? I think these are the 3 things you can focus on, right? I always share these 3 things. Number 1, right? Instead of feeling very overwhelmed with so many things you have to study in each chapter, right? Try to narrow it down. Focus whatever you need to know onto one A4 paper. Right, so here you see this mid-year exam cheat sheet. I can just show you all the actual copy itself. So this is something that I prepared for my own students, right? So what it has is it has all the formulas on 1 page, right? So when you're studying, you don't feel so overwhelmed. Or for example, each chapter, you narrow it down to what are the key things you need to know. Okay, this is something that you can definitely do by yourself because each chapter, you just need to pick out the key points, right? Then you just write it down. That's all you need to know. Don't overwhelm yourself just yet, especially not for mid-year. And for those of you who feel like you already know your content, please don't feel complacent. Doing practices is the logical next step. After you learn something, you need to apply it. Okay. So if you haven't touched your TYS this year, right, I think it's really important that you start doing so. And from here on, right, you realize that, hey, it's a lot better in terms of your answering techniques and stuff. Okay, I'll address some of the answering techniques later on, which is more of the specific way you're supposed to write certain answers. For those of you who have the curated notes, you will know that those portions that are bolded are the answering techniques itself. Okay, but I think these are all things that I'll be happy to share. Okay, if not, let's get started. In terms of time allocation, I have around 40 minutes to cover 2 subjects for chem, another 40 minutes to cover 2 subjects for physics. So I ask for your understanding that I will not be able to go very in-depth. I know some of you might have questions. You can type it in the chat. I will not be able to answer all of them, but I'll try my best if it's within the flow of the lesson itself. That means if it's naturally something I'm talking about, I'll try to address it. But please understand if I'm not able to go in depth. But I promise you the next 1.5 hours is going to be very, very productive. Okay, a lot of these things that I'm going to be mentioning are things your school will not necessarily teach you. Assuming your teacher freaking good, they will, okay? But assuming your teacher needs to cover a lot of syllabus, there are certain nuances and answering techniques that you want to look out for here. Okay, so make sure you have your notes with you. If not, let's jump straight in. So we're going to be doing energy changes first, followed by electrolysis. Once again, if you're taking combined, energy changes is relevant, electrolysis is not. Okay, so what I'm showing here is the soft copy version of the curated notes. So for those of you who already purchased a booklet for your own revision, please take it out and maybe you can write down notes alongside. For those of you without it, it's perfectly fine. This is just my version of textbook. Okay, I call this the Bible. So everything that I want to share is here. So I'm just going to be using this to teach. Okay, so don't be too afraid if you don't have a copy. Okay, you can just refer to the share screen. Okay, so energy changes was one of those topics that was heavily voted in terms of difficult topics to address. I wanted to talk more about this and to also address what are the points that you have to look out for. I will keep it as succinct and as straight to the point as possible. The first thing you need to know when you're learning this chapter is the big overarching idea. The two keywords here is system and surrounding. Of course, we know the main keyword that's going to appear later is exothermic and endothermic. But before you go into exo and endo, I think it's very important for you to understand what's the difference between system and surrounding. When we say system, it is referring to your reactants and your products, aka is referring to your chemical reaction itself, right? Something react with something, this is literally your system itself. So when you undergo a chemical reaction, your energy level of your system will change. So when we use the term energy level, we are describing that of the system. Yeah, so important, remember, when we say system, I'm thinking energy level. When I'm saying surrounding, what am I thinking of? I'm thinking of temperature. Okay, it's very important for you to understand this in order for you to have clarity over the whole concept. Now, let's talk about exothermic first. Exothermic means what? It means my system is releasing energy to the surrounding. So in an exothermic reaction, what are we expecting? Okay, so let's say if this is exothermic. If my system is releasing energy, my energy level of my system will obviously drop, right? Because I'm releasing energy. So my system's energy level will drop. But as I release heat to the surrounding, my surrounding temperature will increase. So this is the relationship between system and surrounding. And that is what an exothermic reaction does. Exothermic reaction, you can think of it as though it is just a way of describing how the energy flows out of the system into the surrounding. Of course, if you go via the other path, which is endothermic reaction, okay, maybe I should use a different color. If you are doing an endothermic reaction, right, what happens to the energy level and the surrounding? Endothermic reaction, I'm actually taking in energy from my surrounding into my system. So my system's energy level will increase because I'm taking in energy. But as I'm taking in heat energy from my surrounding temperature will decrease. That's all. So I just need you to remember this: system, energy level, surrounding is temperature. Do not mix up the two. Okay? And that's how exo and endothermic reaction work. Now, this is the first thing I need you to take down. What I need you to take down next is even more important. There's exactly 4 things I need you to know here. You can ignore the last one technically. I need you to know number 1, number 2, number 3, number 4. There are a total of 4 exothermic reactions that you need to be familiar with. Condensation and freezing, combustion kind of, you get it, right? And neutralization. So questions will simply ask you, they give you 4 options. They tell you which one is a exothermic reaction. You are supposed to know condensation, freezing, combustion, and neutralization. These are the 4 main ones that will be tested. Okay, so look out for exothermic reactions, know this 4. Okay, I know for condensation and freezing, it might feel a little bit weird, but you inside like, condensation, freezing, low-key the vibe is like, it's quite cold, right? So how is it an exothermic reaction? Now, one of the things that I always emphasize on when we're doing chemistry is connecting the dots. So the chapter that energy changes is related to quite a bit is actually kinetic particle theory. So let me show you the part that I would like to share here. Okay, let's take a look at this graph, right? This is a freezing graph. Okay, this is under kinetic particle theory. Okay, so what do I want to share here? When we are undergoing freezing, See the keyword here? Heat energy is released to the surrounding. Heat energy is released from your system to your surrounding, outward flow. Temperature of your surrounding will increase. Therefore, freezing is actually an exothermic process. Okay, I repeat that again. During freezing, heat energy is released. Therefore, it is an exothermic process. Clear? So when we go back to the chapter in energy changes, I want you to be able to see the link, right? Obviously, we first learned condensation and freezing during kinetic particle theory, right? Solid to liquid, liquid to gas. But you need to acknowledge that change in state is exothermic, okay, for condensation and freezing. On the other hand, what you need to know for endothermic, okay, there's actually a few more. You see those that are labeled. If you need to, write this down. 4, 5, 6. Okay, so there's 4 reactions for exothermic. There's 6 reactions for endothermic, which includes melting, boiling, dissolving of ionic salts, thermal decomposition, photosynthesis, and electrolysis. So questions will ask you the same thing. I'll give you 4 choices. Tell me which one of the 4 is endothermic, something like that. So you're supposed to know. I'll show your questions later. Don't be worried. But this is the foundation of the chapter. You need to know which processes are what. Okay? So all of these are already here. You just need to write them down. Okay, I'll give you maybe 30 seconds for those of you who haven't written it down yet. After this, I want to address very interesting differentiation between combustion and thermal decomposition. You have questions, you can type in the chat, but no guarantee I can answer. Okay, but I'll try my best. Okay, very quickly going back up to the exothermic one since there's a request. Condensation, freezing, combustion, neutralization. So 4 for exothermic, 6 for endothermic. This one tends to come out in MCQ. Okay, then this 6 for endothermic reaction. Now, there is actually one very interesting thing up. Okay, a very interesting part that I like to address, which is the difference between thermal decomposition and combustion. This is an area whereby there's usually a lot of confusion. Understand they are completely different things. Even though they low-key feel like they both have heat evolved, right? It's very different. Combustion, as you have just learned, is exothermic. So you actually release heat energy to the surrounding. Okay, heat is generated. This one, if you need a bit of visualization, right, it's like you go for barbecue, right? The charcoal is burning, the charcoal is producing heat. That is combustion. Combustion will always require oxygen. Meanwhile, for thermal decomposition, it's actually endothermic. So instead of producing heat, right, it's actually absorbing heat. Absorbing heat to do what? Absorbing heat in order to break down my compound into smaller parts. So you see how CaCO3 is being broken down into CaO and CO2. So thermal decomposition is actually endothermic in nature. So don't get confused between the two. They are very different. If you're given something and you're wondering, hey, is this combustion or thermal decomposition? One trick I can teach you is to check if it's just a single compound by itself and it breaks down to 2 more, this is thermal decomposition. It breaks down. Combustion, if you see oxygen, most likely combustion. Okay, then for those of you who have already learned low-key still air and atmosphere, I think which is most of you, and for those of you whose schools are faster in organic chem, you see plenty of combustion again. So by then, you'll be a lot more familiar with combustion itself. Ken? Quick quiz, this one, see if you get it. When have you learned thermal decomposition before? Anybody recognize this equation here? Do you all know where you've seen it before? Blast furnace. Okay, so for those of you who are a little confused, right, go back to your blast furnace and metals and take a look again. Yeah, see, some of you know it's under metals. Okay, please not work energy power. Okay, next, moving on. So we already identified the key things. Enthalpy change is pretty straightforward. I won't be going through. The next thing I'd like to talk about is your energy level diagrams. For my combined chem kits, right, this one you do not need to know. Whatever you need to know has just been shared. Is the 4 + 6. Okay, now for the pure ones, please take note here that energy level diagram, this is the correct way to draw it. There are a few things that I'll be looking out for as a teacher. Number one, did you label your axis? Take note that your x-axis here is actually not time, it's progress of reaction. The reasoning is because all the reactions occur in a very short period of time. So you have to draw out, right, maybe in 2 seconds it's over already, okay, or maybe 20 seconds is over. So progress of reaction gives us a better understanding of the progress itself. Next, I would like to see your reactants and products being written on the lines here. Take note that it's not just writing that, but it's writing as per the balance equation itself. Next, I would like you all to be able to label your enthalpy change, which is from where your reactant is to your product, as well as your activation energy. It's labeled as EA because it's energy. The type is activation, so it's EA. Now, I know some schools, right, they don't advocate for drawing double-headed arrow. I think that is usually the norm now. So if you want to follow my advice, is just draw a single-headed arrow, okay, for both enthalpy change and activation energy. You can see the same, all right, for both here. Okay, energy level of your reactants to energy level of your product is your enthalpy change. Here, you observe that for exothermic reactions, it's a negative enthalpy change because energy is leaving your system. Your system's energy level will drop. Meanwhile, for endothermic reactions, you'll notice that the energy change here is actually positive because we're taking in energy from the surrounding. Okay, are the arrows supposed to be double-headed? I encourage single-headed arrows. But for activation energy itself, it is okay if it's double-headed. But really depends on your school and what your teacher prefers. Okay, for myself, I teach my students single-headed, just for safety. Okay, now there's one last thing that I'd like you to write down. I'm a bit lazy to write down, but I want you all to notice the activation energy. Think about it. Which reaction is harder to occur? Endothermic, correct? Can you see that the activation energy here is so much bigger? The mountain that you need to climb here is so much more difficult compared to the smaller mountain here. So on average, in general, you can expect endothermic reactions to be a lot more difficult purely because the activation energy needed is a lot more. Clear? Okay, so this is your energy profile diagram. I can't guarantee it will come out for your mid-year, but hint, hint, it usually comes out. Okay, so please make sure you're clear with what you have to draw and the labeling as well. Okay, if not, next, moving on to bond breaking and bond forming. Now, bond breaking and bond forming, just be aware that your mid-year exam also very likely to come out. One of the biggest obstacles when it comes to such questions is really your answering technique. So I'm going down to how you should answer your questions. Now, how do you justify a reaction is exothermic? Keyword here is energy release during bond forming is greater than energy absorbed during bond breaking. Now, what you want to do is to replace the words products and reactants with the actual products and reactants your question is talking about. So instead of saying bond breaking, bond forming of products and reactants, you want to actually write down, oh, H2 and O2, then H2O, something like that. So you want to change the parts that I've highlighted here differently for your products and reactants to the actual names of your products and reactants as per your equation. Okay, then of course for endothermic reaction, the answering technique you want to achieve here is you want to say energy absorbed for bond breaking, okay, is greater than energy release during bond forming. Once again, replace reactants and product with the actual reactants and products that you see in the question. Okay, I have good questions here. Do we need to include the mole of products and reactants? Actually, the answer is yes. But for now, right now, I think getting the answer is more important, right? So I'm not going with the perfect answer. Okay, but if your answer is more or less what I've highlighted, you usually get the mark. Okay, but yes, if you're able to mention a number or more, it will be even better. Now, for those of you who are stuck, right, you're like, hey, like, okay, I get that this is an answering technique, but how do I remember this? Let me show you the way I teach my own students, okay? So I always say that enthalpy change is by taking bond breaking minus bond forming. Okay, you ignore all of this first. You don't think about this first. You just look at this. Now, when I say I'm an exothermic reaction, okay, is enthalpy change positive or negative? It's negative, right? So if I want to get a negative value, BB minus BF, which value has to be bigger in order for me to get a negative value? Bond forming, right? So if bond forming is bigger than bond breaking, I will get a negative value because it's minus bond forming. Therefore, now if you go back to the answer here and you take a look, exothermic reaction, bond forming is bigger than bond breaking. Can see? That's all. So the keywords then you'll need to say is, energy released during bond forming, energy absorbed during bond breaking. You can use the reverse logic for endothermic. If I want to get a positive value, bond breaking must be bigger than bond forming. So bond breaking greater than bond forming. So that is how you wrap your head around how do you place, which one is bigger than which one. Think about your enthalpy change. Understand that it's always BB minus BF. Can? All right, so this is another important part that I like to talk about. Of course, there is questions that are related to bond energy. Unfortunately, I don't have enough time, but if you want a quick advice, right, there's many pro tips in the notes, right? And this is just one of them, which is you want to draw out the full structural formula, which is instead of CH4 and O2 and stuff, right? You actually draw out so you can see all the bonds. Okay, then you calculate how many bonds you are breaking and how many bonds you are forming. Remember, you break your reactants, you form your products. Once again, break your reactants, you form your products. Break your reactants, form your product. Get it? Okay, then of course in the question, they'll give you different values, right? You have to add up all your bond breaking, all your bond forming. If you take BB minus BF, you get enthalpy change. Clear? Okay, if not, I think that's more or less about it because I don't have that much time. Something that I'd like to highlight here is your hydrogen fuel cell. You might want to pay a little more attention to it. Not saying it will come out, but it can. I mean, for me personally, I found that it's a lot more common in prelim rather in mid-year, but always good to prepare that. Okay, wait. Okay, so the key thing here about your hydrogen fuel cell that I want you to know is that largely we consider it to be a very clean fuel. Your question might be like, why is it like good, right? Why is it clean? Because it's environmentally friendly. As you can see here, the only product that is formed is water. So overall, it is like quite good vibes because like water is fine, right? So they say hydrogen fuel cell is great. Okay, of course, hydrogen fuel cell, if you listen on and you go on when we talk about electrolysis, you realize it's actually closely related because you have reactions at the negative as well as the positive electrode. Okay, that's more or less it. If I can show you guys some of the questions that I was talking about earlier. For example, if you get a reaction like this, instead of trying to do your calculation straight away, the important exam technique here is to actually draw out all your bonds. You go and calculate how many you break and how many you form. Then you can calculate out what the enthalpy change will be. Clear? So this is a question about bond energy. Usually it is not MCQ. Usually it's structured question. It's worth 2 to 3 marks. Okay, so for energy changes, what is it to look out for? Please remember your 4 and your 6, your 4 exothermic reactions, your 6 endothermic reactions. Next, please be familiar with how you're supposed to draw your energy profile diagram. And lastly, go and revise your bond breaking, bond forming. Okay, and if you have time, it will be good to revise on your hydrogen fuel cell as well. Okay, electrolysis is a much bigger chapter, so I like to spend a bit more time there. Okay, so for my combined students for Chem, that's it. Electrolysis will not be relevant, but for those that are taking pure, please stay on. For those that are coming back for physics later on, both physics chapters that I'm covering are both relevant for combined. Okay, that's all. So I will take a look if there's any questions I can address here. I see a couple of equations. Too difficult to... Okay, can. All right, if not, let's move over to electrolysis, shall we? Okay, I know you're here electrolysis, you want to faint already, right? Okay, so rather than going very, very in-depth for electrolysis, my one goal today is in the next 20 minutes, right? My goal is to help you understand electrolysis. Okay, screw all the memorizing things that you gotta do. Okay, I'm gonna tell you precisely what is it that you need to know. But before we can go there, right, you have to follow me with this. I'm going to spend 5 minutes to talk about how electrolysis work. Okay, promise me one thing, don't memorize this. Try to understand it. It is quite easy. I know it sounds like you might say, oh, you're lying, right? How is it easy? Let's see. Okay, follow me through. Follow the logic of what I'm saying. For any electrolysis question, the first step is to take a look at the battery. I need you to know that when the battery is connected to my electrode, based on the battery itself, I'm able to tell what's the charge of my electrode. What do I mean? It's as simple as if I'm connected to the positive terminal of the battery, my electrode on the left will be positively charged. My electrode on the right will be negatively charged. Pretty darn straightforward, right? Just plus and minus. That's all. Next, I want you to be thinking about this. If I'm positively charged, what kind of ions will I be attracting? I'm plus, plus attracts minus, right? So at your positive electrode, you'll be attracting negatively charged ions. Negatively charged ions are also known as anions. Okay, so far, right? Plus, if you're plus, you attract minus. Now, think about it. If my positively charged electrode is a shop, right? My customers are all anions. What do I call my shop name? All my customers are anions. My shop would be called anode. Done. So no need to memorize that positive is anode, negative is cathode. Gets a bit confusing, especially later when we do with electric cell. You just need to think about what are the customers you're attracting, and therefore you have your shop name. Similarly, for your negatively charged electrode, it's quite clear that you'll be attracting your positively charged cations, which is why your electrode here is known as your cathode. Done. Okay, so here you have your anode and you have your cathode. The last thing I need you to think about is my anions come to the anode, right? Your customers want to do something at your shop, right? So what are your anions hoping to do? For example, a common one would be a Cl minus, right? So Cl minus is your customer, comes to your shop. What does it want to do? Cl minus just wants to turn back into Cl2. Right now it is negatively charged. It is hoping that it can turn back into neutral. They are always hoping to go back to neutral. Okay, so what is your Cl minus hoping to do here? It's hoping to engage in a reaction that looks like that. Now, more importantly, from Cl minus to Cl2, is this oxidation or reduction? Oxidation state of Cl minus here is -1. Cl2 is an element by itself. Oxidation state here is 0. Therefore, from Cl minus to Cl2, this is an oxidation reaction. In other words, what am I trying to say? At the anode, customers are hoping to get oxidized. Who are your customers? Your anions. You can, of course, do the same for your cathode, right? A common cation might be Na+. Na+ is hoping to turn back into Na. Oxidation state of Na is +1. Oxidation state here is 0. Therefore, as I gain an electron, I undergo reduction. So what are my customers, my cation trying to achieve at the cathode? They come to my shop for what? To get reduced. So as long as you remember that they are always hoping to go back to their elemental form, in this case, Cl minus to go to Cl2, Na plus to become Na, you have it already. So what I need you to memorize going into an electrolysis question is this keyword. Anybody want to guess what it means? Anode, oxidize, cathode, reduce. Write that down for me. Okay, anode, oxidize, cathode, reduce. Yes, the longer line is the positive terminal of your battery. Because if you know your AOCR, you know what are the customers coming to your anode and cathode and what they're hoping to achieve, you are pretty much done understanding this chapter. This is your foundation. You got it already. I repeat one more time. You use your battery, you start off, figure out what is plus, what is minus. Think about what customers you're attracting. Think about what you're called. What's your shop name called? And lastly, for your customers coming to your shop, what are they hoping to achieve? Okay, if you get that framework in your head, right, electrolysis will be simpler than it seems. Okay, of course, I'll be going in depth into different electrolysis setup, but this is the basis of what you need to know. Okay? Now, if we are done with the AOCR part, let's actually jump straight into different setups. There's a total of 4 electrolysis setups that I'd like to share here, starting with setup 1. Okay, going into a question like this, it's very important for you to read your question and take a look at what kind of setup we are discussing. We are discussing molten sodium chloride. Okay, so for molten sodium chloride itself, you need to understand that the ions present, there's only 2 of them. There's Na plus, there is Cl minus. So always look at what kind of setup it is and what are the ions present. Okay, next, if I only have Na plus and Cl minus, at my anode, I attract N ions. There's only one freaking N ion. Of course, this guy is going to get discharged. That's it. Can you see this is a case of oxidation? Right? AOCR, right? So you want to take a look, AOCR. So your N ions get oxidized here. There's only one cation ion, so your cation ion will get reduced here. That's it. Okay, so the simplest case is a molten state and there's only 2 ions. Both customers will get served perfectly. Life is great. Okay, this is for molten. Now, another setup that you will see that is a lot more common is actually your dilute ionic compound. The sun is very hot. Okay, when you're dealing with a dilute ionic compound itself, now is a bit different. I call this setup 2. Right, the second setup here, please understand that when we say dilute, dilute means got water. Water means got H plus, got OH minus. So as you can see here, these are now the ions that are actually present. Okay, now at your anode, it is still AO, which means anode still oxidized. But I want you to realize that now there are 2 customers. There's Cl minus and there's OH minus. So now got 2 customers, right? Which one do you serve first? Okay, that is when you need to go back to this thing called the ease of discharge table. Okay, your school notes will probably have some version of it. Okay, shouldn't be that difficult. Okay, so under the under the ease of discharge, you will see here that OH minus is a lot easier to discharge as compared to your other compounds. So between OH and Cl, can you see OH is further down the list, right? So it means you will get preferentially discharged. So when OH and Cl fight it out, the customers that win, okay, the one that win is OH minus. OH minus is like the VIP customer. So OH minus will get served first. Now, this equation here, please pay attention to it, because this equation here, if you are trying to write it out for the first time in the exam, there's no way you're going to get it right. Okay, so please take note that 4OH minus turns into O2, 2H2O plus 4O minus. This equation itself is very important. Clear? Okay, so just pay attention to OH minus. The reason why I say it's important is because if you go back to your ease of discharge, can you see OH minus will always get selectively discharged? Right, it's like the VIP customer. So more or less when you're doing dilute, right, straight away OH minus will be discharged. Okay, then of course in your cathode undergoes reduction. So between H plus and Na plus, if you go back to your ease of discharge, you'll see that H plus is a lot easier to discharge compared to Na plus. So H plus will be preferentially discharged. Okay, so this is the equation that you get. If you combine the 2 equations into one, this is the equation that you get. Okay, so I'll just give 30 seconds pause here for those of you who want to take down anything. Okay, this is for setup 2, a dilute setup. Why is the sun so hot today? You're good? Okay, so setup 2 done. Let's move on to setup 3. Okay, the third kind of electrolysis setup that you will see is your concentrated setup. Concentrated means there is still water, but now something else you have to consider is that there is this thing called your concentrated effect. Now, to address what this is talking about is that your cations no change. Between the two, H plus will still get discharged. But when you're doing dilute versus concentrated, I want you to see how your halogens used to be not as important as OH. OH is usually preferentially discharged. But when you have a concentrated setup, I want you to see how now OH minus is being pushed back. Your halogens are going to get discharged instead. So the key difference between setup 2 and 3, dilute versus concentrated, is that in the concentrated setup, your halogens will get discharged instead. Which is why here at the anode, it is still AO, right? But between my two anions of Cl minus and OH minus, Cl minus will get discharged instead. Meanwhile, at your cathode, your H plus is still the one getting reduced. You'll get the difference? So only the anode will change when we change it from dilute to concentrated. So that is the key difference between the two. Okay? Ken? Okay, to get the overall equation, for some of you that are wondering, is about combining the two half equations. Okay, I won't have the time to fully go through, but to make it straightforward, you just make sure the electrons are balanced, convert it to an ionic equation, put back in your spectator ions to form your chemical equation. Okay, key thing is make the electrons the same. This one is the same. Okay, now down to our final setup. In the first three setup, we were using what we call inert electrodes, which means they don't react. In the fourth setup, the final setup for electrolysis, you're going to be using reactive electrodes. If the electrodes are reactive, take note, your anode will oxidize. AO still works, but instead of you having customers come to your shop, right, instead of you serving your anions in NO3 and OH minus, take note, your whole shop is undergoing renovation, which means you're not going to serve any customer. So what's happening instead is that your anode will oxidize. So it will dissolve. Okay, your shop closed, right? You can't be serving any customers. So what's happening is that your shop is being torn down, right? You're trying to renovate the place. So your anode is still oxidation, but it's just your anode dissolving. At your cathode, cathode will undergo a reduction reaction. So inside your solution, you had Ag plus and H plus. Between the two, Ag plus is easier to discharge, which is why Ag plus is selectively discharged. So if you really put an object at the cathode, the silver would form onto the object itself. This is otherwise known as electroplating. So how do we do electroplating? My anode would have dissolved, then it will form onto my cathode. So I always put my object on the cathode itself. That is the most important part. Okay, so for the fourth setup, just remember we're dealing with reactive electrodes. So these are the four main electrolysis setups. Of course, there might be some variations of each, but usually it boils down to four: molten, dilute, concentrated, reactive electrodes. But this is not the end of electrolysis because it's what I call a 4+1. What is the +1? +1 is what we call your simple electric cell. Now, you need to know the difference between electrolysis and simple electric cell. Electrolysis, we have a battery. The battery powers chemical reactions, right? Then we get anode, cathode, whatever, the four different setups that we have done. But for simple electric cell, it is the reverse. The goal here is to rely on chemical reactions to produce electricity. Normally, you either have a light bulb or you have a voltmeter. So remember, if you see a battery, electrolysis. You see a voltmeter or a light bulb, it is simple electric cell. And in a simple electric cell, you will have two metals of differing reactivity. The more reactive one will become the anode, it will oxidize, and you see here it gets dissolved. At your cathode undergoes reduction. Same thing, AOCR. So here, your cations gets discharged instead. What you do need to know is that the further apart the two metals are within the reactivity series, the greater the voltage. Okay, that is what you need to focus on for your simple electric cell. Okay, is there any difference between the word selectively discharged and preferentially discharged? Not really. Usually schools will accept both. Okay, so what is electrolysis about? 4+1. 4 different setups for electrolysis. one electric cell setup. And the big idea, remember at the start we did it, you get your plus, you get your minus, attract N ions, K ions. Oh, my short name is called anode, my short name is called cathode, right? Then AOCR. If you keep those few things in mind and you try more questions, you start to realize that electrolysis is not as scary as it seems. Of course, if your foundation in redox reaction is weak, it will affect your electrolysis. Okay, so for redox reaction itself is quite important if you want to do well for electrolysis. So I hope with whatever I shared, hopefully these two chapters that might seem very intimidating are a little less intimidating. Okay, I acknowledge that I wasn't able to go in depth. I probably covered like 20% or 30% of what I usually teach in my group tuition. But to be fair, I only have 40 minutes with you guys. So I have to keep it brief. I wanted to just share the most important parts. Okay, for simple cell itself, okay, the anode is actually the negative electrode. Yes, that's correct. Okay, but I don't want to go into that. That one might make it a little very confusing. But for those of you who know what's happening here, your simple electric cell is actually your battery. And if your more reactive metal is giving out electrons, it forms the negative terminal of your battery. Okay, that's why your more reactive metal is negatively charged. Okay, but I think what I'm more concerned with is after I say so much, right, can you all do questions? Okay, so we have 3 questions for energy changes, 3 questions for electrolysis. Per question, I'm going to give you around 30 seconds to 1 minute to try. You guys see if you can get it right. Okay, let's start with question 2. Okay, you don't need to type in the chat. You just, in your head, you think about the answer. Then I'll tell you all the answer and you'll see if it makes sense. Okay, I'll start breaking it down. Energy is released, meaning we're thinking of exo or endo. Energy release, right, from my system to my surrounding. So when we say energy release, we are thinking of a exothermic reaction. Okay, electrolysis, exo or endo? Endo, right? Remember the 4 and the 6, right? So electrolysis falls under endothermic. So cannot be my answer. Forming of hydrogen molecule from 2 hydrogen atoms. This is talking about bond forming. When I do bond forming, is it exo or endo? Bond forming is actually exothermic. So this is of course my answer. Okay, fractional distillation of crude oil, not really relevant. This one is not really energy release or energy absorbed. This is not part of any of the 4 and the 6. All right. Lastly, photosynthesis, remember, is part of my endo. All right. Therefore, answer here should be B. So this is what I mean by you need to learn your 4 and 6. All right. Then you're able to come out with your answers. For fractional distillation, there's actually a further explanation. To just draw it, to talk about it very quickly, fractional distillation involves you turning a liquid into a gas. Then after that, you condense it, right? So actually the whole process of like boiling itself, turning it from liquid to gaseous version is actually a process whereby we consider it to be endothermic. Okay, boiling is endothermic, which is why sometimes it can be argued that this, of course, is endo, it will not be the answer. But to be very fair, I think it's a little bit weird too, because fractional distillation involves condensation too. And then condensation is exothermic. So whatever. I just need you all to know that A and D cannot be the answer. Okay, and bond forming is definitely exothermic. Okay. Okay, next question 4. Okay, I don't have time to repeat the 4 and 6. If anything, you can go back and review the video recording. I'll try to upload the ASAP. Okay, but what I'm saying is the 4 exothermic and the 6 endothermic reactions. Okay, next question 4. Sorry, I really want to answer all your questions, but in the interest of time for everybody that's here, I have to keep pushing on. If not, I won't be able to cover everything. Okay, let's take a look at the statements one by one. Statement A, activation energy is Y minus X. Y minus X actually gives you what you call your enthalpy change. Agree? Okay, so statement A is not true. Activation energy for the reverse reaction is X. That's not true. Activation energy for the forward reaction is X. Can you see? Right, the hill I have to climb, that is activation energy. X is the activation energy for the forward reaction as N2 and H2 turns into NH3. So this is forward, this is backward. Backward means my ammonia is turning back into nitrogen and hydrogen. So this statement here is not true as well. C, enthalpy change for the reverse reaction is positive. How do we know that? If you look at your forward reaction, you have a negative enthalpy change. Therefore, we can conclude that the forward reaction is exothermic, which means the backward reaction will be endothermic. Okay, so if I'm endothermic, my enthalpy change would be positive. That's why statement C is true. Okay, statement D is just not true. The enthalpy change for forward reaction is here. Okay, is here like that. If you're talking about the, I already drew it, right? Is this one here. Ta-da! Okay, enthalpy change for forward reaction is this. Clear? Okay, so analyzing your energy profile diagram is another kind of question type that you need to be prepared for. Okay, I know some of you might not be very familiar with this forward and backward thing because something your school might not have taught. Forward just means that you take the path of the forward, like from reactants to product. So you go via this path like that. Okay, and reverse reaction meaning you're thinking how your NH3 turn into N2 and H2. So it's just the direction is reverse. Okay, it's either you're taking the slide down or you're climbing up the slide, if you get my analogy. Okay, last question for energy changes. Okay, this one I'll just give you a full minute to think about it before I'll go on. $5.52. Actually, I have no time. Don't have time for y'all to try. Let me jump straight into what I need y'all to look out for. So the exam technique is what? To draw out the full structural formula, right? So we have 2 of H2, which means I'll be drawing out my first H2, and I'll also draw out my second H2. Next, I have O2. O2, remember, is a double bond. If you're not too sure why, please go back to your chemical bonding and do a revision. And then we form 2H2O. Okay, so the trick is to draw out everything. Then it's a lot easier. Remember that the working here is delta H equals to BB minus BF. I am taking all my bond breaking minus my bond forming. So what exactly am I breaking? Can you see I'm going to break this and this? I break my reactants, right? So I'll break 2 of my HH bonds. Can you see? Right? So breaking 2 plus what? What else am I breaking? I'm breaking a single OO double bond. So plus 498. Minus, what am I forming? I'm forming 1, 2, 3, 4. So I'm actually going to be forming 4 different OH bonds. So I'll take 4 times 4, 6, 3. Okay, you do your calculation here, you get your final answer. Okay, anybody have the final answer? Okay, minimally I know, right, because this is a combustion reaction, it will be a negative enthalpy change. Okay, but I don't have a calculator with me, but it's either A or B. Okay, you're going to do your calculation. Anybody got the answer? A, is it? Okay, perfect. A. Okay, so negative 482. So if you get a question similar to this in the structure, just remember the exam technique that I've taught you here, which is to draw out all the bonds, break all your reactants, form all your products. You draw out everything, you're able to see what bonds are actually being broken and form a lot better. Okay, that's all for energy changes. Next, let's move on to 3 commonly tested questions for electrolysis. Let's take a look at the first one. All these questions are TYS questions, by the way. Okay, so this one you can find it in the TYS if you need to recap a bit more. I just picked up the more commonly tested ones. Okay, for those of you who already feel overwhelmed when you see this, right? I want you to be thinking about the AOCR that we've been talking about. Okay, now recap. The first step when it comes to analyzing an electrolysis question is to figure out what ions I have inside my solution. When I say solution, it means that there's water. So definitely there's H plus and there's OH minus. Next, my solution contains copper sulfate. It also contains magnesium sulfate. Now, when we say negative electrode, what does it attract? Negative electrode attracts cations, correct? And how many cations do I have? I have a total of 3. This one, and this one. Right. So now I have 3 customers. Which customer will I serve? Some of you might be thinking H, okay? But I want to go back to our notes. You take a look at the ease of discharge carefully. This is your reactivity series. Notice how copper is even easier to discharge than H+. Can see? Copper is lower. Copper is a VIP more than H+. It's easier to discharge. Therefore, between the 3, the one that will actually get discharged is copper. So what will be produced at your negative electrode attracts cations. Among the 3, copper will be selectively or preferentially discharged. Do you all see how I broke down the question? We take a look at the question. We label and write down all the ions that's present. Negative ions, we go down to, okay, negative, I attract positive. I attract cations. Among the 3 cations, which one will be discharged? Copper will be discharged. That's how you get your answer. Okay, you don't just jump in and try to bring in different facts. It gets very, very confusing. Okay, if you have 2 sulfate ions, doesn't necessarily means it's concentrated. Okay, and even if it's concentrated, it doesn't change what will be produced at your negative electrode. Okay, let's try question 13 now. Okay, once again, let's try it together. We have dilute aqueous sodium chloride. For those of you who are familiar with what I shared earlier, this is like macam my setup 2, right? Then this one is my setup 3, concentrated. Okay, now for dilute aqueous sodium chloride, once again, we write out, okay, in this setup, what is present? We have Na+, we have Cl-, we have H+, we have OH-. In fact, for setup 3, it's exactly the same. But what is the difference? Do you have an inkling of what it is? For my dilute, okay, H+ and OH- will be discharged. If you're not too sure, refer back to your ease of discharge. So at the positive electrode, I'm attracting negative anions, right? So among the 2, Cl- and OH-, which one will be discharged? OH- will be discharged. Therefore, I'll form oxygen. Okay. For those of you who blur, right? Why oxygen? Isn't OH getting discharged? Please, 4 OH- forms O2 plus 2H2O plus 4E-. This is the gas that's formed. So OH will form oxygen gas. Okay, at the negative electrode between Na+ and H+, your H+ gets discharged, you get hydrogen gas. Now, the more important one is for a concentrated setup. Concentrated setup, no diff, H+ is still discharged. So no surprises on that. But take note, between OH and Cl-, who will get discharged? Remember, your halogens now become your VIP when it's concentrated. Okay, so if your halogens gets discharged instead, of course, you'll be expecting Cl to discharge, you'll get chlorine. Therefore, answer here is C. So you need to be able to differentiate between the different setups. Am I talking about dilute or am I talking about concentrated? Because if it's concentrated, now the anion might change. Your cation usually doesn't change. Okay, because the ease of discharge is the same, be it dilute or concentrated. Okay, final question, question 14. This is about electric cell. How do we know? The moment you see voltmeter, you're like, bruh, this is confirmed electric cell. Okay, next, I have magnesium, I have silver. Remember that your more reactive metal, which is magnesium, will dissolve. Your more reactive one forms the anode, it will oxidize. Your magnesium metal would oxidize to form Mg2+. So which statement about the cell is correct? Electrons are passed from the magnesium electrode to the silver electrode through the electrolyte. No, it will pass through the wire. Can see? Your electrons are going to be shooting out from your magnesium to the silver electrode. The cell shows that silver is more reactive than magnesium. Nope. Magnesium is definitely more reactive than silver. The magnesium electrode loses electron. Can see? It shoots out electron. So this is true. Then the silver electrode is supposed to be reduced. Because this is AO, this is CR. So answer here should be C. Clear? This is a 2020 question. So one of the latest questions that O-level has set. And this is about electric cell. So just remember your more reactive one will dissolve and shoot out electrons. Okay, and you see a voltmeter, just remind yourself that's an electric cell. Okay, so I hope with whatever I've shared, while it's briefed, I hope there were very important tidbits of information that will help you out at your mid-year. So hopefully electrolysis as well as energy changes will seem less scary than it actually is. Okay, so for all my Chem Bio students, that's all to the Chem segment. If you want to take part in a giveaway, come back around 6:30, I think. That's when I'll start the Kahoot. All right, the Kahoot is very fair. If you take Chem, Physics, or only Chem, or combined science, right, it doesn't matter. You can still do the Kahoot. So whoever wins will get the curated notes. Okay, so for my Chem students, come back around 6:30. Okay, in the meantime, for my Physics students, please stay on because I'm going to do next 2 chapters on current electricity as well as DC circuits. But before that, I'm going to give everybody a quick 2-minute break to go pee, go grab a snack or wash your face. Okay, then I'm going to start with the physics one on current electricity and DC circuits. Okay, so for these 2 chapters for current electricity and DC circuits, I'm actually going to keep it a little bit more straightforward. Rather than focusing on the very complex stuff, I'll try to tell you exactly what are the formulas you need to learn for electricity. Because normally the fastest way to be very good at electricity is to make sure you know your formulas well. Then straight away after, I'm going to show you all certain question types to make sure that you guys are aware of like what kind of questions can be set. Okay, and I'll tell you a few tips here and there. All right, so let's start with current electricity, shall we? Okay, for those of you who are back, maybe can you give me a thumbs up so I know whether majority is back before I get started? You out there? Why got crying emoji, guys? Don't sad eh? Public holiday, you're here listening to me. So poor things, yeah, it's like long weekend, like no long weekend, right? I know for most of you. And because for those with mid-years, I mean, probably you're just like studying. Okay, life sucks, but you know, life goes on. Life of a Sec 4. Okay, come, let's go through chapter 17, current electricity. Now, for current electricity itself, we can narrow it down to focusing on the formulas first, as you can see here. Let's talk about them one by one. So what formulas do we need to know? The very first formula for this chapter is current equals to charge over time. They're like, why is current symbol I? Okay, it's because the capital C represents the unit for charge. So bobian, I means current. Okay, Q means charge. The definition for current is known as the rate of flow of electric charge. So you can see the formula here. I want you to write it down somewhere. Okay, that is the first formula that you need to know. Okay, what you need to know about current is that current always flows from plus to minus. Electron flow is obviously the reverse, so from minus to plus. To measure current, we usually use an ammeter, and the ammeter is always connected in series. Okay, so that's what you know. The first thing you need to know is current is the rate of flow of charges, Q over T. The next formula that you actually need to know is voltage. This one is very underrated. Okay, a lot of people ignore this. Okay, what is voltage? Voltage is energy per charge. So for the example, if I say something is 3 volt, what it actually means is that for every single charge, it contains 3 joules of energy. This is what we mean when we say voltage. Okay, so V is actually equals to E over Q. Now let's take a look at a more in-depth study of voltage. Voltage is actually a unit. Voltage is a unit for both electromotive force as well as potential difference. Both have the same unit. What is the difference then? When we use the term electromotive force, please recognize that it's used strictly when we're describing the battery. Meanwhile, we use potential difference if you're trying to describe the component, which is why you see in the definition here, Electromotive force is the work done. Work done and energy is the same thing, right? By the source, which is your battery, to drive your charge around the complete circuit. For those of you who have difficulty understanding what this means, you know, in the F1 race, the car usually goes to the pit stop, it gets refueled, they change the wheels, then it goes again. It's exactly the same for a battery. Your charge, right, is the car. The car goes one round around the circuit, it goes to the pit stop, it gets refueled, it gets pumped out again to go another round. So EMF is referring to your battery, the amount of energy provided to your car to drive it around the circuit. Right, that's EMF. Meanwhile, potential difference is the work done to drive your charge through the component. So in an F1 race, hypothetically, I know it doesn't exist, but let's say there are certain obstacle course. So for you to get past the obstacle course, maybe you need to use your booster to power through it, right? Because there's a certain resistance in the component. So the amount of energy needed to pump my way through the component is potential difference. The relationship between the two is usually that, let's say hypothetically, I have two light bulbs. This is 3 volt, this is 3 volt. So for me to pass through both, in total, I need 6 volt to begin with. So when I leave my pit stop, my charge will be supplied with 6 volt to pass through both components. And when it comes back, it'll come back with 0 volt. So the relationship is that if you add up all your potential difference, you actually get your EMF. Okay, once again, both users, oh, that was very loud. Both users voltage as the unit. Clear? Okay, so the second equation or second formula you're supposed to know is V equals to E over Q. The next formula, I think this one you all know, V equals to Ri or V equals to IR, whatever. This is the basic formula. Okay, this one I think most of you should be aware of it already. Okay, if you have problem remembering, right, for me personally, when I was a student, in my CCA, Victoria and RI were the powerhouses. Okay, so I always say Victoria equals to RI because they're both very good. Okay, yeah, so that's how I reminded myself. But whatever, right? V is voltage, R is resistance, I is current. Okay, the last formula that you actually need to know is R equals to rho L over A. Okay, this one here, you might be wondering what is rho. Rho stands for resistivity, which is dependent on the material that you use. But most of the time, right, hint, the material is the same. Both are copper wires. So the resistivity will be the same. This is length and A is cross-sectional area. Okay, I'm just going to write area. You are able to use these different values to figure out the resistance. I'll show you all the question type that can come up later on as well. Okay, but these are the 4 main formulas that you need to know for electricity. I equals to Q over T, V equals to E over Q, V equals to Ri, and R equals to rho L over A. If you're okay with this, I'm going to try some questions straight away. Okay, electricity is a lot about knowing and applying it. So let's take a look at this question. What formula should we be using? I equals to Q over T. That's all. So if I have 60 charge over 15 seconds, my answer here is as straightforward as 4.0 ampere. Answer is C. That's all. Okay, but I just like to warn you all a bit. I selected this question just nice. The units is in 15 seconds. But sometimes if your school is evil, which is the case most of the time, they'll write 2 minutes. 2 minutes, remember, you don't divide by 2. The SI unit for time is seconds. So if you ever get something in minutes, please remember to convert it to seconds by taking times 60 seconds. This is 120 seconds, for example, right? Then you'll do your calculation accordingly. So one key pitfall that you might make is that you think that time is in minutes. No, time is always in seconds. So just pay attention to that if it appears. Next question, let's take a look at question 10. This is another common question, especially in MCQ. Do you all know your definition for potential difference? Okay, remember, potential difference is work done. Work done and energy is the same thing. To drive, electron or charge. What is your sports car? Your sports car is the charge itself through the component. All right. So if you come across a definition question like that, please make sure you know how to define it. Okay, so definition is just as important. Now, the next question is one of those questions that I can't guarantee it will come out, but it have come out so many times that if it comes out, I want you to be prepared for it. This question is not the easiest, but let's discuss it together. Pay special attention to my working. The formula that you'll be using here is R equals to rho L over A. But instead of rho L over A, I want you to go one step further. Write this down. R equals to rho L over pi R squared. Cross-sectional area of a wire is circular, which is why the area is pi R squared. We're going to see how using this formula makes a world of difference. Now, we have two wires. We have wire X, we have wire Y. Wire X is just a normal wire, right? It has 9 ohms. It's rho L over A. Okay, rho L over pi R squared, sorry. Okay, it's 9 ohm. We're going to be doing the same for Y. Okay, let's take a look at how Y works. Okay, we're trying to find the resistance of Y. So we say that it's rho L over pi R squared. Okay, but to be more precise, it is not L, because here we note that wire Y is twice as long. So instead of L, we're going to be writing 2L. You get what I mean? Because the length is twice. So instead of L, I write 2L. Now, this is the most important part. The diameter is 3 times larger. If my diameter is 3 times larger, my radius is also 3 times larger. So instead of writing R squared, what I'm going to be writing is 3R bracket square. I repeat again, diameter is 3 times larger means my radius is 3 times larger as well. To find area, it is pi R squared. Therefore, when I do my calculation, this is what I'll get. I'll get 2 rho L over 9 pi R squared. Okay, 2, 3 square, right? 9. So if I isolate and I do my math here, right, rho L over pi R squared is 9 ohm, which means my working here can be as simple as 2 over 9 bracket 9. The resistance of my wire Y is 2 ohm. You get it? Okay, so why is the radius not 6 times? Fair question. This is my diameter. This is my radius. If my diameter increased by 3 times, my radius will also increase by 3 times because it's directly proportional. Okay, we are comparing the diameter between the first wire and the second wire. So when your diameter increased by 3 times, radius will also increase by 3 times. So when they say diameter, don't be confused. Diameter and radius would mean a similar thing. Are we good here? So what is the key thing I need you to learn? Pi R squared. So try to start learning instead of rho L over A, try to remember rho L over pi R squared. Okay. The truth is that for combined science, they usually stick with this. But if you're taking pure, right, they usually go with this. This is an actual O-level question. I'm not setting this question, right? But this is one of those that are more commonly tested. And I think it's very important for us to know. Okay, so once again, going back to the equations here, this one here, it will be good if you write rho L over pi R squared. Okay, you can thank me when it comes out in your exam. Okay, but I mean, only thank me if you get it right. Okay, so remember, diameter affects the radius by a factor of square. There are many similar questions that you can see in the future. Okay, so last part very quickly, just make sure you go and study your Ohm's law. Ohm's law, usually most people can say, oh, current flowing through metallic conductor directly proportional to potential difference. But a lot of us, right, forget to write the second half, provided that all other physical conditions remain constant. Okay, when we say something is ohmic, it means that the current and the voltage will be a straight line. Resistance is constant. Non-ohmic means you'll get a curve. Okay, the two non-ohmic, the moment you see the word filament lamp, right, you're like, most likely it is non-ohmic. So that's what you pay attention to. Okay, that's all. If not, I wanted to quickly move on to DC circuits. For DC circuits, instead of talking a lot, I'll be using questions to solve instead. Now, what are the foundation that you need to know? You can see on this summary page. If you want to, you can quickly copy it down. Okay, For DC circuits, the main thing is you need to understand the difference between a series and a parallel circuit. In a series circuit, current is constant throughout. It's like one big river, right? The river just flows. A river, at any point, the current is the same. Meanwhile, for a parallel circuit, your river flows in, it splits up into 3 smaller streams. For my job students, it's like your tributaries, right? So it splits into 3. Then these 3 streams will recombine back later on to form back the main river. Okay? For potential difference, I believe I mentioned this earlier. If this is 3 volt and this is 3 volt, for my car to go 1 full round, it needs a total of 6 volt. However, if my battery here is 6 volt, I want you to recognize for a parallel branch, these are all separate branches. So if I give off 6 volt, right, this is like a food distribution center or like whatever lah. Basically, each household will receive the same amount of voltage. So in parallel, right, potential difference is actually equal across each branch. Remember they are very important. If you can see the relationship, right, it's actually like that. Can see? Equal, 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 equal. Plus, plus. So one is equal, the other one is the sum. Okay, so the relationship between current and potential difference is as such. For resistance, I believe if you have done a little bit of practice, this one should be quite clear. Resistance for series, you just add everything up. But resistance for parallel, you need to use this formula. Okay, depending on how many resistors you have. Okay, now I want to use actual questions to go through them instead. Let's take a look at question 7. Which formula will we be using here? We will likely be using the resistance formula, right? So let's do them one by one. For W, how would the working look like? 1 over R equals to 1 over R1, right? Which is 1 over 10 plus 1 over 20 plus 1 over 10. So how much is 1 over R? 1 over R, wow, let me do some mental sum. 5 over 20, right? Which is 1 over 4. So how much is R? R is 4 ohm. So you write 4. If I'm wrong, let me know. I'm just doing mental sum. Sometimes my brain not working. This one, you just need to add everything up. The one that I wanted to go through was network Y. Because this is parallel, right? But this is in series. So what you're going to do, right, is you first calculate how much this 2 resistance is, then you add the 20. So what I mean is this. What you want to do is you do 1 over R equals to 1 over 10 plus 1 over 10 first. That gives you 1 over R equals to 1 over 5, right? So R is equals to 5 ohm. Then you take this 5 ohm, you plus the 20 ohm, you get 25. Okay, so to arrange it from smallest to largest, it should be W, Y followed by X. So answer here should be B. Yes, you can put to the power of -1 if you want to, if it's a bit easier. For those of you who are wondering what that means, is instead of doing this working, I'll write R equals to 1 over 10 plus 1 over 20 plus 1 over 10 to the power of -1. Okay, this is math lah, more math than physics lah. Okay, but for me, both workings doesn't make a difference. Okay, whichever you're more comfortable with. So this is the basics for resistance. If you ever get a parallel in a series, settle the parallel first, then do the series. Next, let's try this question. This is one of the most important questions ever. Classic. Okay, I give you a bit of time to read through before I start talking about it. Okay, the thing with DC circuits and the thing that I always teach my student is that in DC circuits, there isn't just one way to solve the question. There's usually multiple ways you can solve the question. So I'm going to show you, actually there's 3 methods to solve this question, but I'm just going to show you 2 methods. You guys can decide which one's easier for you. Okay, but for my own students, I always teach them to learn all the methods because the first time you're doing it, you can use the first method. The second time when you're checking for it, you use the second method. If both methods give you the same answer, you low-key know that that is obviously the correct answer. Okay, so I'm going to be teaching you all both methods today. You guys see if it makes sense. Okay, and then you decide which one is your first choice and which is your second choice. Let's go with the first method first. Okay, this first method follows a very simple idea. You simply need to understand that to find my reading on my voltmeter, to find voltage, I simply need my resistance and current, right? Obviously, resistance here is not going to be that easy because you need to find the resistance of this and this followed by this. Okay, so how do we find that? I'm going to start by doing and settling these two first. Remember, it's very similar to the previous example. So how would the working look? I would say 1 over R equals to 1 over 1 plus 1 over 2.5. So I try to solve how much is my resistance for those two that are in parallel. Okay, so working wise, it will look like 1 over R plus, how much is this? 3.5? Something like that. Anybody can quickly type in your calculator and tell me the value. 1 over 1.4. Whatever, I'm just going to go with this, okay? So after that, you need to flip it around, right? So R equals to 1.40. If the value is wrong, let me know. After that, what do we do? Now that you know that the entire thing here is 1.4 ohm, you add up with the 1 ohm. So what's my total resistance? My total resistance is 1.4 plus 1, right? So it's 2.4 ohm. Now the question is as good as solved because now you just need to do V equals to Ri. So I know my V, I do not know my V, but I know my total resistance is 2.4. And how much is my total current? Take a look. The current here is 5, current here is 2. If I recombine back these two current, for those of you who are wondering what's happening, you follow my highlighting. The current used to come in the main circuit in series. Then your current split up into two smaller currents. Can see? Then after that, it recombines back into the main current itself. In other words, my total current is actually simply 5 plus 2. Because when I add both current up, I'll get the main current in the circuit. Is there a calculation error anyway? Let me quickly type just in case. But the working is there already. Then you should be able to get your answer. 3.5 divided by 2.5. 1.4. Oh, the whole thing is 1.4. That means my R here is how much? 1 divided by 1 point. Whatever, I'm just going to write it out. Okay, I think there was a bit of miscom for those that were sending in your values. Okay, let me change it up a little. The working is the same. It's just that the values I need to change. Okay, so this one equals to 1.4. This one is equals to 0.71. 1.71, 1.71. Okay, by the end of the day, I believe the answer that you should be getting here is how much? 1.71 times 7. 12. Answer is C. Okay? You all get what I'm trying to say? Okay, so the first method is what I call the total resistance method. So by finding my total resistance and I have my total current, I can find my total voltage. So this is the first way I'm solving the question. Okay, next I'm going to be talking about the second way of solving the same question. Now, this one requires a little bit of a deeper understanding. For those that can follow, I think it would be great if you're able to listen up closely to see how it works. Now, what I need you all to know is that what is voltage again? Voltage is the energy required to cross the entire circuit, correct? Here, I got current, I got resistance. V is equals to Ri. So when I take current times resistance, do you see here? 5 volt. 2 times 2.5 is also 5 volt. What this means is that whether I take the first lane, the upper lane, or if I take the lower lane, going through either of them will give me the same voltage. Or in other words, I will require 5 volt to pass through either lanes. Lane 1 or lane 2, no difference. Both require 5 volt. If I know that my current coming in is 5 plus 2 is 7 ampere, same thing, I take current times resistance. What's the voltage here? 7 volt. Can So imagine if I'm a charge passing through. I go through here, right? How much do I need? I need 7 volt. Now I reach a cross juncture. Should I take the top lane or the bottom lane? Whatever, okay, I take the bottom lane. I need to use 5 volt. And then I go back to the circuit. So in total, how much volt did I use? 7 volt plus 5 volt. 12 volt. That's it. So you're just going to attempt to find the potential difference across each resistor, and you're going to add it up. Whether I go through the bottom lane or the top lane, both lanes would require a total usage of 12 volts per journey. Take note, I do not add the 5 plus 5, because for a single car coming through, it will either take the top path or the bottom path. It will not go through both. So either case is either this 7 plus this 5 or this 7 plus this 5. Either way, it gives you 12 volt. Okay, so this approach is by using voltage to do it instead. There's one last method using potential divider, but I probably won't go through that route today. Okay, how I get 7 volt is as simple as knowing that my current is 7 ampere, my resistance is 1 ohm. V is equals to Ri. Right, my resistance is 1, my current is 7, my voltage is 7. So I'll need 7 volt to pass through this component. That's what I'm saying. Okay, Kenna? So I hope this is clear. This is one of the classic questions. Like I said, there are 2 different ways you can solve it. Either using total resistance, total current to find total voltage, or you can study the potential difference individually to decide the EMF equals to the sum of your PD. Okay, final question. Okay, this is another classic question. I'll just give you all 30 seconds to read through. Yes, current is 7 because it's a 5 ampere in the first branch and 2 ampere in the second branch. So total current is 7. Okay, let's take a look at this question itself. Now, for me personally, I like to play around with some values. So I say hypothetically my battery is 6 volt, right? Let's consider the relationship between the branches. This is lane 1, this is lane 2. I need you to know that both lanes will receive 6 volt and 6 volt. Okay, but obviously this 6 volt will be split between these two. So what happens when the LDR receives more light, right? Understand that L1, no matter what happens in the second branch, what happens to your neighbors doesn't affect you, right? So you're just here, you continue to receive your 6 volt, your brightness will stay exactly the same. Okay, now between the two, this is when we need to bring in potential divider. Okay, how does potential divider work again? So potential divider is this concept whereby we state that the more your resistance, the more voltage you receive. Okay, so I just need you to remember this. The larger the resistance, the larger the voltage. If you're wondering why, it's a simple formula of V equals to Ri, right? Assuming your current stays constant, because the two are in series, a larger resistance will get you more voltage. Therefore, if you go back to this question here, when light shines on your LDR, what happens to the resistance? The resistance drops, which means the voltage it receives will drop. If your LDR receives lesser voltage, your light bulb will receive more voltage. Why? This 6 volt is going to be divided between the LDR and L2. So if your LDR decides that, oh, resistance drop, I'm going to take lesser voltage. Now L2 will take more voltage instead. So the 6 volt is being split up between the two. That is potential divider. So if L2 receives more voltage, the brightness will increase. This is how you do the question. This question very common. Okay, so you need to understand how your LDR works as well as how voltage works. Okay, that will give you a much better shot at conquering DC circuits. DC circuits, to be very frank, right, there's around 20 different question types. I was only able to go through 3, but I picked up the 3 that I think are quite likely to come out. Okay, so apologies, I'm not able to go very in-depth. Okay, but at least now you have a better shot at DC circuits. Okay, for those of you who are keen, you can very quickly copy down these portions here. Okay, for the formulas for electricity. Double check. Okay, I think most of them I make you write down already. Okay, maybe even P equals to VI. Okay, this is just like a formula sheet that I prepared for my students, but I thought quite relevant lah. So you can take down whatever you need to take down. Okay, and if not, that's about it for the physics segment. Okay, just 30 seconds for you all to write down stuff before I proceed on to the exciting part. Are you ready to win a free set of notes, guys? Winner takes all. The difference, potential difference and potential probably means the same thing. I think more of that, it should be understanding the difference between EMF and potential difference. That one's a lot more common. Okay, so in summary, let's talk about what we have covered in the short 1.5 hours. Short, but quite intense, right? Okay, I hope it was productive. So we went through energy changes and electrolysis, all right? And then for physics, we went through current, electricity, and DC circuits. I pointed out a few commonly tested questions, but I think the goal is still to do more practices on your own. But hopefully, going through this helps you be a little more prepared for mid-year exam. Okay, so all contents today were shown from the curated notes, is the soft copy. If you already have a copy, great. You probably took down a lot of notes today. For those of you who want to purchase, you can just scan and order, means on our website and whatever. You don't have to buy the booklet, okay? If your school notes are good enough, you can just use it, okay? But for those of you who want just a more condensed version of everything, I think this is a good place to start, rather than having to start from scratch and make all your own notes, okay? Inside, there's a lot of pro tips. So for my subjects, for my one, okay, I write a lot of exam techniques and stuff. So give it a consider if you are interested. Now, if you are still struggling and this is your O-level year, this is more for the Sec 4s, right? You can consider coming for my group tuition or the crash courses. Let me elaborate a little more. Honestly, for my group tuition, right, most of them are almost full already. There's only a few sessions that left that have slots, okay? So let's say if you're at a stage now, you finish your mid-year and you realize that, wow, I need more help, right? And you want to work with me on a week-on-week basis, this might be it for you. But for the majority of you that don't need tuition, right, you can consider the crash courses. I'll share a little bit more later. For the group tuition itself, it's a weekly 2-hour session. So every week we'll be going through something new. All learning materials are provided. You get free curated notes, you get exam papers, everything. Okay, everything's inclusive as part of the fee. Let's say if you're not too sure and you just want to try, the first session is free. Okay, which means you can just come down and sit in for one session. After that, you decide if you like my teaching. If you don't like it, obviously you won't come back. Okay, but if you like it and you want to stay on, go ahead. Okay, the slots here, as you see, is as what it is. If it's 2 slots less, really means 2 slots left. Meaning, even if you apply after the 2 slots are filled, I can't fit you in. Okay, so this one really first come first serve. Most of my classes are already full. Okay, for the time slots on Saturdays and stuff. Question here: how are the curated notes compared to the free notes? The free notes on the website are a lot more summarized. It's still super helpful. Probably just before your exam, you want to do a quick revision, right? The free notes are sufficient. But if you want more in-depth notes, right, that's when the curated notes come in with more exam tips and exam techniques. There's also a lot more work examples in the curated notes itself. Each class is around 6 to 8 texts. Okay, so the number of slots there give you an idea of how many students are already in the class. Okay, so if not, let me move on. If you have other inquiries, you can still just text me. You guys know my contact number, right? Okay, but for the bulk of you, right, this is something that might interest you. Like I shared last year, few hundred students attended our crash courses, and we did a survey, and across the board, I think almost everybody gave a 9 or a 10. They found it to be really helpful. The crash courses this year will be held and happening during the June holidays. These are the prices as you see. If you find it's a little expensive, you can go and sign up with a friend. Then both of you will enjoy a 10% off. Okay, the classroom is only big enough for us to accommodate 30 packs. So it's really first come, first serve. And there are people signing up already. So I can't guarantee that there will still be slots if you sign up in late May. So if you want, you can go and quickly find out more details. If your friend's interested, then you can sign up for it. Now, what would we be covering for the crash courses? So if you like today's session, right, realize that the teaching was good and stuff, right? Today was honestly the tip of the iceberg, all right? During the crash courses, I will have a lot more time to go through all of the chapters more in depth. I'll be recapping key concepts. What are some commonly tested questions we'll try together on the spot, like what we did today? I'll tell you what are the most common mistakes that are made, and more importantly, how to avoid them. And for paper 2, you have to write down answers and stuff, right? I'll be going through precise answering technique, literally what you have to write down, as well as some exam strategies and revision tips. So if you sign up for the crash course, you actually get a complimentary set of the curated notes, which means you don't actually have to buy it. So you just come for the session You'll be given a set, you'll sit through, I'll be running through you all the content. Okay, all of this is happening during June holidays itself. Okay, where is the crash course? Is actually near Yishun MRT. All right, the whole space, as you can see, is quite vibes lah. I mean, I kind of like it. That's why we chose the place. Okay, as you can see, it's quite spacious. It's a big classroom. It's fully air conditioned. Overall, I mean, bring a jacket. Okay, but overall, it's quite comfy. It's a walkable distance from the MRT. Okay, so we have a how to get there guide if you sign up. Okay, for the chemistry one itself, these are the dates. It's happening on 6th June, 13th June, and 20th June. So for each module, it's actually 3 hours, as you can see, from 1 to 4 p.m. The topics covered will differ for each module. So if you want me to go through the entire syllabus with you, you should be signing up for all 3, and there's a package rich discount. But if you feel like you only need help for specific topics, you can come for those as well. So meaning you only come for module 2 and module 3, or just module 1. That's possible as well. Okay, but of course, if you come for all 3, it'll be cheaper lah. But you get the idea. Okay. For physics, these are the topics that I'll be covering for each module. Same thing, this one will be happening during the June holidays itself. These are the topics that we'll be covering. Okay, not forgetting for combined science. Combined science itself, it will be split into 3 modules, but you only need to come for 2, right? Because if you are chem physics, you'll come for 4th June, 18th June. If you are chem bio, you'll come for 18th and 25th. All right, this is happening on a Saturday. For the bio side, it will be Singwei that will be covering it. I'll be covering for both physics and chem. Okay, so maybe if you just do chem bio, you'll see me for chem, you'll see Singwei for bio, but you'll get the curated notes as well. Okay, if not, that's all. So if you're keen to sign up for the crash courses, just go onto our website. All the details are there. If you're signing up with your friend for the 10% discount, just write both your names in the promo code section. Okay, if not, let's head over to the Kahoot quiz. There's a total of 8 questions. If you answer them well and you win a set of curated notes. Okay, so good luck to the winner. Okay, let's go. Wee. The Sec 3 one, the person that won scored 10 out of 10. So let's see how much your score this time around. But this week one, I set it such that you don't need to know your stuff to score. Okay, a lot of it was actually about the things that I've just mentioned about the crash courses. Hey, y'all don't put like weird name, man. Later I don't know who the winner is. Okay, I give you all 1 more minute, then I'll start already. Yeah? Two. 30 more seconds for those that are still joining. See, y'all got listen to me share just now. It's time to go. Okay, starting in 5, 4, 3, 2, and let's go, people. Don't worry, the question is very easy one. What got people get wrongly? Oh my god, help lah, guys. I mean, I did take bio last time, but it's been a while since I taught. Okay, so oh, this one will be fun. Not an endothermic, huh? Remember your 4 plus 6? Do you remember that? Okay, freezing, unlike what you think, right? It's very cold. No, freezing actually absorbs energy. Okay, so just understand that. Freezing releases heat energy. It's actually exothermic. Boiling is the one that is endothermic. Okay, but I think majority of you got it right. If you're not too sure, please go and do your revisions again. Okay, the 4 plus 6. When will it be held? The place quite nice, right? I really like the place. Like, it's quite vibes. Okay, I think most of you got it. Wow. Leaderboard changing fast. Ha, this one at the start. Remember how many years I've been teaching? Shit, it makes me sound very old now. Damn it. No, I'm still young, okay, guys. I'm still in my 20s. Not sure, just guess, guys. I started teaching in 2014. That was when I started, 2014. Hey, wow, actually a lot of you got this right. I was quite surprised. What? Wow, Vera doing very well, keeping her lead. How much are the fees? Read carefully, a lot of them are very close. Okay, of course, if you find it to be a bit more expensive, you can always sign up with your friend and both of you will get 10% off. Okay. Wow, not bad. Okay, so most of you were aware. Wow, Vera in green in the lead. Okay, sign up with another friend. Do you get a discount? Actually, last year, most people that came with a friend, and it's a bit more fun. But I mean, of course, you can come solo too. It's no issue. I think compared to also kind of depend on which subject lah. I mean, this one cannot get it wrong, right? I just literally share about it. Oh, Chloe, coming in strong. Second last question. What, bruh? You know where is it? Okay, it's actually at Yishun, but it's very near the MRT lah. I mean, last year we had people coming down from the east and the west. Double point, Try to identify what these reactions are, right? Combustion, neutralization, photosynthesis, condensation, which is endothermic. Double point round. Okay, so make sure you are familiar with that, okay? Let's see who won. Okay, congrats to SY. Just make sure you text me on Telegram or whatever after this. Okay. Thanks for participating, everyone. I hope you all enjoyed the session. Okay, and all the best for your mid-year exams. All right. So I'll be around for the next 2 to 3 minutes if y'all have any questions. But if not, really, I hope y'all do well for your mid-years, and I hope this session was helpful. I'll be uploading the recorded version onto our YouTube channel. So just make sure you tune in if you need another session. But I hope you enjoyed the session. Okay. So thanks for spending time with me on your public holiday. Okay. Yep. Hope you enjoyed the session. Hope it was useful. What is this? You're all Picassos, yeah? Yay, thank you. Enjoy the rest of what remains of your last long weekend before your exams. What is this, guys? Yeah, at least I see a lot of heart shapes. Thanks for spreading the love, everyone. Thank you, thank you. Okay, okay. I hope it was productive. That's most important, right? Learn something here. Okay, so I'll be around if y'all have any more questions for the next 2 minutes. If not, I'm gonna log off to and have my dinner before my lesson. Hey, hey, don't request control of the screen, man. Decline, decline. Any tips for physics practical? For physics practical, it's important to revise those chapters that tend to come out, and you need to know that there's also very contextual content for each chapter. What I mean is that if you're dealing with a chapter for electricity, you still need to know your formulas and stuff. So I mean, when you're doing practical itself, make sure that you spend time to revise those important topics too. It's important to read through your practical stuff and study common sources of error. For example, heat loss to surrounding and stuff. So those are all things you can revise beforehand. Are there definition questions for paper 2? Yes, they can be. If you're unsure what definitions you need to study, you can refer to your syllabus code as well. If you have the curated notes, all the definitions that you need to know is at the back of the curated notes. It's a compiled formula sheet. Okay, is there any mnemotic to memorize exo and endo? Yes. One common one that I like to teach is that when you say exothermic, I always think of the firework, right? So firework is like heat energy is released, right? So it's hot, right? So that is exothermic. And then for endothermic, for bond breaking, I always think of energy absorbed, as if you need to master energy to break a bond. Yeah. Okay. Okay, if not, that's all for today. So thank you, everyone. And I think I'll be logging off here.